Anybody else need their test, Pamela? I've got yours. Eric, I've got yours. There you go. And you have the other. Okay. Yeah, turn in what you have. All right. Any questions over the over homework? I did pass out something, a bunch of stuff, and one of the assignments didn't have a name on it. I put up on the top name, so if that's you, you need to let me know who you are. Okay, what problem? We're working at a 6.2. Which one? Number what? 13? 13. Cosine squared, tangent cubed. So integral cosine squared x tangent cubed x dx. Now, because we have so much to do today, I'm just going to get right down to this, all right? One thing you could do, this isn't the only thing, you could switch everything in terms of sine and cosine. Tangent, by definition, right, is sine x over cosine x, so tangent cubed is sine cubed x over cosine cubed x. And what you could do then is you could cancel two of the cosines, so cosine squared there cancels, and we'll have just one cosine left on the bottom, right? So our new integral is sine cubed x over cosine x dx. Is that all right? Now it's just a matter of trying to choose your u and du properly. If you try and let u be equal to sine x, which would probably be the thing that you would most naturally want to happen, du being cosine x dx appears in the denominator, which you don't want. So I should have done that in red. Sorry, that's not a good idea. Yeah. But if you try it the other way, right, if you try doing your u is cosine x, your du then would be negative sine x dx. You actually have sine x up here, but you have three of them, don't you? And you only need, or you only want one of them. So what you can do here is peel one sine off. Whoa, this is way down here. Peel one of those sines off. So how about like this? Give myself some room. Integral sine squared x over cosine x times sine x dx. So you can see that I kind of have the sine x dx, right? I've kind of got that. I'm off by a sign, but I've got it right here, right? I've got the u down here. Here's my cosine x. I've got that. I just need to take care of this sine squared. So how can I take care of the sine squared? Well, I can turn it into 1 minus cosine squared x. And why would I want to do that? Because that'll become 1 minus u squared, won't it? Is this making sense? Okay, now you have some options here. I'm going to keep it like this. I'm going to go ahead and separate this into two fractions. 1 over cosine x minus cosine x. Then I have my sine x dx. So all I did was I took, the 1, put it over cosine x. I took the cosine squared x, put it over cosine, so it's split into two fractions. And that gave me two terms. And then I still have the sine x dx. And at this point, again, you have some options. I would probably go and break it into two integrals. You don't have to do this, but and then you could do each of these integrals. Each of these integrals is just a basic substitution. Still with me? Yeah. Okay, so on this first one, u is cosine x. Du is negative